Okay, Assalamualaikum dan salam sejahtera. Today we'll continue the next topic, which is on electric meters. So what actually are electric meters? Electric meters basically are devices that to measure electrical characteristic, diagnose condition of loads, and check whatever the machine has problem or not. So what does it measure? Basically it measures ampere, volts, and ohms. Okay, the most common one for ampere, to check ampere we use ammeters, volt we use voltmeters, and ohm we use ohmmeters. Okay. Electric meter maybe exists in two types. Actually, there are two types. The first one is digital meter, the other one is analog meters. Digital meter show value or digital numeric display, while analog use needle and calibrate scale to indicate the value. So here you could see the analog and digital one. This is analog. This one not sure analog, I think. Okay, digital. So below is digital, above is analog. Basic principle: most electric meters measure by use of magnetic effect of current, electric current. This is how the electric meter function. Okay, and then when the electrons flow through the conductor in the electric circuits, the magnetic field is created around the conductor, as shown in doesn't have. As shown in the figure below, the magnetic field is used to move the needle of the meter back a certain distance, which represents the amount of characteristic volts, ohms, or ampere that being measured. The stronger the magnetic field, the larger the movement of needle. The weaker magnetic field, the smaller the movement of the needle. Okay, here is the figure actually. Okay, so here is the magnetic field that created when this conductor is carrying current. So what happened to the needle? The needle move far or move less accordingly to the strength of magnetic field. Type of electric meter. The first one is ammeter. Ammeter is an electric meter to measure the current flow in electric meters. There are basically two common type of ammeter in industry today. The first one is clamp-on meter, clamp-on ammeter. The other one is inline ammeter. The clamp-on ammeter is the most popular because it's easy to use. You can simply clamp the jaw of ammeter around the conductor or wire that have a load, have current in it. The analog ammeters and the analog clamp ammeter and digital clamp ammeter are shown in next figure. So these are the clamp, analog and digital. Okay, this is clamp one, this is inline. Okay, why inline? Because this is one straight line, positive to the negative one. They doesn't directly towards this line, but it been cut off. They cut and then they put one towards the positive, the other one towards the negative sides. That's why it's in line. Never clamp the jaws of ammeter around two wire to obtain an ampere reading. Why? Okay. If the currents, this you need to think why. If the current flow in the wire are opposite, are they often are the ammeter read will be 0 and the current will flow and cancel each other out. If the current flow are not opposite, the ammeter will read the current draw in both conductor. In either case, we will obtain the incorrect reading, which could cause you incorrect diagnosis of the problems. Okay, this is actually why the answer lah. The answer why you should not clamp on two wires at the same time. So the first one will cancel each other, opposite directions. The other one you not will get the correct reading. And then to obtain the correct reading of ammeter, when this method is used, dividing the ampere draw, read by the number of loops going through the jaw of the meter. Figure below show the ammeter of the conductor loop through the jaw 3 times. So this is now 1 loops, 2 loops, and 3 loops. So whatever you have here, when you read it, the correct reading is divided by dividing the meter reading, which is 4, by the number of loops. Here you see this is the needle show that this is 4 amp, but it has 3 loops, so 4 divided by 3 you got 1.33 amperes. Remember, meter reading should always be divided by number of loops carried through the jaw of the meters. The other one is voltmeter. Voltmeter is used to measure the amount of electromagnetic force available in circuit or load. The voltmeter use 2 leads that are connected to jack that lead to internal wiring. So we have positive and negative, and then directly on whatever you want to test. To obtain the reading, the 2 leads must touch or connected to the conductor supplying the load or to the circuit that transfer electromagnetic force to the meter. Here is how it means used. Okay, just connect one to the positive side, the other one to negative side, and we got the voltage. Most common in voltmeter, which read both voltage and resistance. The other one is ohm meter. The ohm meter is used to determine the opening conditions of a circuit or a component. The ohm meter can be used to find the open circuit, open component, or direct short circuit in the component. It also can be used to measure actual resistance of circuit or a component. Now this multimeter is commonly used combination of the triple purpose ohm meter, voltmeter are combined in individual purpose meters. 3 conditions that might appear on the scale of ohm meter. So first one, if you test, this is the whatever the fuse that you test. So we got the first one in 0. So what does it mean? 0 means there's no resistance or it being short, no measurable resistance. Second one, you measure some sort of resistance, because this one is 15, so it means this is 15, this is kilo ohms or ohms. Alright, the next one is this one. We have it infinite resistance, means the fuse may be blow, can be cut off, no reading, so we get an infinite reading here. Okay, next one, component and symbol. There are several components that are used in air conditioning and heating, refrigeration, such as loads, contactors, relays, magnetic starter, switch, safety device, and transformers. Each component has particular purpose and symbol. For example, the first one is loads. Loads are electrical devices that consume electricity to do useful work. For example, lamps, motors, bulbs. Size of the load can be vary from device from small current draw, such as light bulb, and small fan motors, solenoids, and large motor could upwards until 100 amperes. The next one is load are more important part of heating, cooling, or refrigeration, because it has to do all the work in the systems. These are the loads. Resistance heater to supply heat to the building. This is motor when you apply to rotate whatever you need to be rotated, and solenoid to do whatever you need to be done. Okay, you supply current, then this produce work. Then we have this is motors. Okay, A motor is an electrical device that consumes electricity to rotate the device in electrical system. Motors are used in industry to rotate, such as compressor, condenser fan motors, pump, and other devices that require rotating movement. Here are the compressor, condenser fan motor, CFM, on the short name, which is pump. So everything needs motor to operate. Motor are the largest and the most important loads in heating, cooling, and refrigeration system. The symbol for motor use is alright, these are the symbols. When you draw a circuit, these are symbol of motors. Most commonly used symbol, this one. Alternate symbols, this is also motors. Heater. The next one, heater are loads that are found in many systems and wiring diagrams. Heater takes electric energy and convert it to heat. In some cases, electric resistant heater are used to heat the home or house. A heater might also be used to heat a small object or area. The symbol for all heater are the same, only the later designations tells you specific why the heater is used. This is a heater, like the resistant actually they put over there. Heater, this is crankcase heater, CH, SUPPH, supplementary heater. This is what it said that what heater is used for. This is supplementary, this is crankcase heater, and so on is heater because of the symbol CH. And then we have signal. A signal light is used to show the piece of equipment is operating or that is operating in unsafe conditions. So signal lights are usually energized when a piece of equipment or component is started. Signal lights come in variety of color and are not limited to the color. So as you can see in air conditioning system in your home, for example, there are several lights. So this is signal, actually they want to assign it to user to know whether the system is operate or not. When you see the green light, then the system is now operating. If it doesn't have any signal, any light at all, so you could think that the display unit is kaput, for example, or the light itself is kaput. And then the symbol for all lights are the same. These are the red lights we have here, R in the middle, G green light, and we have blue in the middle. This is blue lights. Solenoids. Solenoids are devices that created magnetic field that when energized and cause some action, so electric current control some element in the system such as relay and valve. The solenoid are considered loads because it consumes electricity to do a useful work. This is solenoid used to operate a relay. This is solenoid valve with a coil. So what happened actually over here? It doesn't have simulation. So let's see later on whether we could find one video regarding how solenoid function and all that. The symbol of solenoid is like this, very simple. Not a fuse, but only one go up and one go down. Contactor and relay. Contactor and relay are devices that are open and close a set or sets of electric contacts by action of solenoid. They are electromagnetic switch. So actually they work together with the solenoid. This is relay and this is contactor. Contactor are higher voltage to open or close electric contact, while relay is for lower voltage and to prevent loads by giving signal or command to contactor to trip. Contact and relay are play important parts in control system of any air conditioner, refrigerator, heater, and the symbol is the same. So but consider the conditions. Alright, these are the symbol of the contactors. Some symbol relay and contactor. This is open pole. this is closed pull. Mean this is no current flowing. This is the current is flowing because it being closed, and the current can transfer from one point to another point. Next one is symbol for relay or contactor. Either symbol can be used. This is the symbol Magnetic starter. Magnetic starter is the same type of device as contactor in terms of ampere rating of the device, but magnetic starter has a means of overload protection in it where the contactor has none. So this is magnetic starter. Actually, the purpose is to protect. The symbol is like this. This one. Okay. Switches. All electric switch each a device that open and close to control some loads in electric current. So electrical switches can be open and closed automatically by temperature, pressure, humidity, flow, and other manual forces. The symbols also indicates that it's initiating the action of the switch. Disconnect a switch is used to open and close the main power system in the piece equipment or loads. So this is switches. The symbols depend on the conditions. Means this is in open conditions. So single pole, single throw switch. This is only one single pole, single throw, single pole. This is one pole, single throw, only one throw, one throw. Input and output terminal. Example, I use a lamp, single pole, single throw. This is double pole, single pole, double throw. Single pole, double throw. So we throw it above or throw it up. So you connect to a single pole. Then this example for single pole double throw, whether it need to connect with the lamp or this one is LED. Then we have a double pole single throw. And the other one, example of it, this is double pole double throw. Okay. Then we have a 3-pole fusible connection. Push button switch. Switch is used to open and close a set of contact by pressing the button. Symbol can be normally close or open switch. This is a switch. Symbol for normally close, push button switch. Normally close. This is symbol for normally open, push button switch. Why is it normally open? Because it's always open. Why is it normally closed? By it always loose. Why it been pushed? Only by push it move. Okay. And then thermostat. The most important type of switch in control systems in mechanical operate switch is which is the thermostat. Why? Because you need to control the temperatures, whether to close or not the temperatures. For example, here we have a open on temperature rise. So as been taught before this, this one the how to say that, the throw, I don't know how to say this line. This line is being put above this dot. So when the temperature is high, it will push from this line and disconnect from this pole. So when temperature rise, this heating, the whole line will not have a current come up here and then not connected to the other one because being open. And then we have a cooling thermostat, close on temperature rise. This one is another one. he put this line below this dot, so when the temperature rise, and then this one will be touching, this line will be touching to the dot, and the current will be moved. This is symbol of this is thermostat actually, and you have in industry. Pressure switch purpose is to determine whether it's open or closed on rise or fall of pressure. So this is open on rise of pressure, this is closed on rise of pressure. So because I will put down or put up, so this is high pressure switch, this is low pressure switch, okay, and low pressure switch. So when the pressure is too low, then this one will open. This pressure is too high, then this sensor will be open. Safety device. Three components. These components be protect from adverse conditions such as low voltage, high ampere draw, and overheating. The fuse is effective against large overloads, but is less effective against small overloads. So this is fuse safety device. Thermal overloads can also be in line with the voltage which break the power point to the component that being protected. The symbol are depending on the type of safety device. This is a symbol of fuse. Okay? Symbol of thermal overload, this one. And we have last but not least, transformer device that increase and decrease the incoming voltage to the some desired voltage. So we have a transformer over here. This is from the symbol like this. So all the symbols actually you need to remember. Okay. Transformer are used in industry mainly in control circuits. The symbol is this one. Okay, basically this is all the symbol that you need to remember. This is A type. So what is A type? We see later on. Okay, here we have a single pole, single throw switch, hot gas solenoid, so relay, coil, and so on. Let's have a look at it. This is when you start H over there. When the humidity is high, then this switch will be closed, then the electric will be low. Okay, A is symbol of switches, B is symbol of loads. This is whatever load we have. C is symbol of safety control. This is safety control over here. So we have a hot gas solenoid, relay, coil, red signal light, compressor, heater, crankcase heater, and so on. And we have a D is symbol of contact and relay. D is this one. So we only have one. This is from D. D is 1, 2, and 3. This is contactor and relay. So last but not least, we have E, symbol of transformers. Alright, thank you very much for your listening. Thank you. Assalamualaikum dan salam sejahtera.